Hello, my name is Alonzo Francis Aguilar. For my discussion 7 video, I will be going over substitution and elimination reactions with an emphasis in nucleophiles and bases. And we're going to identify what a nucleophile is and a base, and when should you use them. So let's begin. So, what are nucleophiles? Well, a nucleophile is a atom or molecule or ion that has an extra pair of electrons that could be used to donate, so then it can form a new pi or double bond. And that's basically what a nucleophile is. So what is a base then? So a base serves the purpose of removing a proton from a beta carbon, so then the electrons can form a new pi bond or double bond in between the alpha and beta carbons. But the halide is removed, and the halide that is removed, or the thing that is removed, is called the leaving group. So what are the differences, you may ask? So the difference is that the nucleophile can be visualized and can be seen forming a new bond, because it's going to form a new double bond or a pi bond, and the strength of its forming this ability is called nucleophility. And with the bases, they tend to accept a proton, and the relative strength of this ability is referred as basicity. And right here I have listed some strong nucleophiles, which with strong nucleophiles, you are looking for anything negatively charged. So you got your HS, your iodine, your RS, your bromine, your chlorine, your OH group, HS group, your cyanide, your N3s. And with strong bases, you want your alcohols, your RO groups, your LDAs. With your weak nucleophiles, you want something that is neutral. So we're looking things like water, your ROH groups, your NH3 groups, ammoniums. And with weak bases, you're looking really for your CH3 groups, your NH2s, or your tosylates, anything that's negative and bulky. If it's just large, that's just a red flag that it's in weak base. So when should you use a base? So bases are used to, you're really going to look at your elimination reactions, so like your E1s, your E2s. Bases are excellent for these reactions because they fulfill the role of removing a proton from the beta carbons, so then the electrons can form a new pi bond. So with your E1 reactions, they need both a weak and nucleophile and a weak base. This is because the weak base can take away the proton from the beta carbon, and then the nucleophile can replace that the leaving group, which is eliminated, and form a new bond in its place. Because it's eliminated, there's free space, it moves in. With E2 reactions, you need a strong base to complete this, because with E2s, they are secondary reactions, so they want to be completed in one step. So that's why it's super dependent and relying on the removal of the hydrogen, that's why you need a really strong base. So think of an alcohol. So when should you use a nucleophile then? You should use a nucleophile. Like, nucleophiles are typically favored by substitution reactions. So your SN1, your SN2 reactions. Because, well, with your substitution reactions, the whole purpose is you come in with what you came out with. So with your SN1 reactions, you don't need typically a strong nucleophile, because this is a two-step process. So it doesn't have to rush to be completed in one step, because it's first order. It's a first order reaction. With SN2 reactions, the strength of the nucleophile does matter though, because it is secondary. It's a secondary second order reaction. So with second order reactions, they want to be completed in one process at once. That's why the strength is relative. The strength of the nucleophile is relative to the process. But that has been my presentation. I hope I cleared or made something simpler. But if you have any questions, please reply to my video and I'll be glad to answer them. Have a good weekend.